Hi everyone. So today I'm going to walk you through one of the Leetcode question named Reorder list. So this is how you do it. So they're giving you the example of list like this one from 1 to 2 to 3 to 4, and you have to reorder it to from 1 to 4 to 2 and to 3. And the second one is the one from 1 to 2 to 3 to 4 to 5. You have to reorder it to 1 to 5 to 2 to 4 and to 3. So by looking at this, you can figure out the way to do it is to when you read 1, then we come to 5, and then it comes back to 2, then come back to 4, and then it's come to 3. So the algorithm for this Leetcode by myself is I'm going to separate the list into half. So for the example 2 right here, I'm going to separate it into two halves. So one and the other second half will contain from 3 to 3. And after that, I'm going to merge the two lists. So it will be 3. And after that, I'm going to merge the two lists. So it will be 3. Oh, sorry. Actually, it's gone from 1 to 5 to 2 and to 3. So you see, it looks exactly like the example 2 result right here. So the way we do it is first, we're going to find the middle of the linked list. So first we need the fast and the slow pointer, right? So first, the fast pointer is equal to head and the slow pointer equal to head. And then we will create the head of the two linked lists. Alright. So like I said, when we finish separate into two linked lists, we're going to reverse the second linked list, right? So I'm going to create a node named L2 and going to reverse and this node going to contain the reverse of the second linked list. We can use the head of the second linked list with this low. So now we're going to reverse the linked list. So we're going to create another function going to reverse the linked list. Okay. So in order to reverse a linked list, so here's my algorithm. Okay. So for example, we're going to have a linked list look like this, right? So first we're going to create a current pointer with equal to the slow pointer, which is the head of the first, with the head of the second half, and going and another reverse pointer is going to equal to node. Then we're going to traverse the current pointer until it's reached node. So every time we traverse the current pointer, we will create another node, which is the next node. So this node is going to equal to current dot next equal to next, right? So after that, we will point the current to the reverse. So yeah, we're going to point the current to the reverse. So right here, the no pointer, right? And then after that, current is going. We repeat the while loop to traverse current. So current will come here, and then next will come here because next is equal to current.net, right? And after that, we will keep repeating the loop. Current.net will again point to here, which we just said the reverse. And then it will keep traversing until curve reach null pointer. So when curve reach null pointer, we will get a traverse length, and the reverse will be here. So we're going to return reverse, right? Because now is the head of the reverse of the second length. So here we're going to create a reverse pointer equal to node current pointer equal to the head of the second length, and then we're going to traverse the current the first half. So here I'm going to define the merge function. Okay. So the way we're going to do it is now let's okay. So we have two linked lists, right, and we need to merge it. Right? So first we will start at the head of the linked list 1. So first, before we point to L2, we need to create another node in order to keep the pointer to this one right here. Because if we point to L2, we don't have the reference to the pointer of this one. So we're going to create another pointer name L1 dash next. So this is going to be the pointer point to this one. So then we also want to create an L2 dash next in order to reverse the pointer of the pointer of the address right here, because after we point the head of the L1 to the head of the L2, L2 is going to point to this one right here. So we're going to lose the pointer to this one. So that's why we need to create the two pointer for the L1.net and the L2.net. Right? So this is how we do it. So we keep repeating these thing until we reach here. So going to down here, and then we go up here, then we go into down here, then we go into up here, then we go into down here, right? So the condition to stop this loop is when L1.net is equal to no pointer. So if it's equal to no pointer, we don't need to point to no. We just break the loop and we're done. And that's when we get the merge of the L1 and the L2, right? So here how to do it. So first you need going to create pointer list, right? And then we will make the head of L. Oh, I'm sorry. We need to create the page condition where L1 y to L2 dot next to L to the L2 underscore next, right? So we would continuously doing it until it reaches the null pointer, and after that this merge function will return the same as the result shown right here. Like I just said to you, the algorithm I make from the beginning. So let's try to change the code, right? So for the first half, we will get 1 to oh sorry, I think I missed something. Oh, right here. It's supposed to be only one equal sign. Oh, and oh, forgot to use the parentheses to close. Oh, I see. I put it outside the class, so put it here, close parentheses, and here. Oh, reverse. Sorry, I make a lot of mistakes. L1 is not undivided. L1 equal to head. Like 59. Oh, I'm using. Okay, I'm using the uppercases. Okay. Okay, and there we have it. Thank you guys for listening to my explanation. I hope you like it. I know that my English is not very good, but I hope you understand what I'm saying and what I'm want to point out for this question. Thank you.